Our last topic will be presented by Aku, and he will tell us about insecure strings around us and tell us a little bit about Flipper. So please welcome Aku.
よろしくお願いします。Akuです。My speech will be in English. So basically, we will talk about things that we think are kind of secure, but they're actually not. And I'm Aku. I'm a software hardware developer, like architect. I've been designing like secure systems for long, more than 15 years, and my last and the most important thing that I did is actually the Flipper. Flipper is a pen testing Swiss knife that allows you to test different access systems, and we will talk today a little bit about what kind of systems right now exist in the world, how secure they are, and how we can make them even more secure. So basically for today, we will talk about what security is in modern IT, what security is in Internet of Things, what kind of Internet of Things actually exists, and we will talk about pre-Internet of things. So basically it will be infrared, RFID, low frequency, high frequency. It will be NFC, SubGhz, iButton, and a little bit like general ideas on how to live with it. And we will start with world before IOT. So you know that S in IOT is actually means security. It's kind of a known fact, and we already had like big incidents when, for example, some router manufacturers completely forgot to secure their system, and then we have botnets with terabits of traffic, and they just appearing out of nowhere. And we have a couple interesting projects that are actually trying to find all those devices, like Chodan, and still we have a lot of issues. And those devices is actually running like full-fledged operation systems that actually have all security tools like for years, and you can test it, you can like test all kinds of different things inside of them before actually releasing products. And even with all those tools, we totally failed like to deliver good products. And even big vendors like TP-Link, like D-Link, they have a lot of devices which are vulnerable, allows attackers to access to those devices from outside and do quite nasty things, including hijacking like payment data, etc. So, and this is like a top of the iceberg. And this is something that we can test. And we already have a lot of tools to do that. And there are things which we think are kind of secure, but they're not. And it starts with really simple things around us, like infrared remotes. We do think that, okay, and this industry, we're completely neglecting any kind of security. And we think that since it's local, it doesn't impact on our life, and if something happens, the impact will be local. But it's not. In some cases, it can be really scary, and it can cause the loss of money and damage to infrastructure. So for infrareds, it's usually remotes for your air conditioning, for your lighting, any kind of like small systems. It's super cheap. It's one of the oldest like protocols and medium for accessing, controlling different like home appliances. Then we have RFID. It's not actually one thing. It's a lot of different things. And by RFID, when we're saying RFID, we're actually meaning that there is a low frequency RFID, high frequency RFID, UHF RFID, and they've been around us for long. It's starting with access control system that we already have in this building, and different like toll collection systems, different payment systems, including your smartphone, which actually got like either Apple Pay or Google Pay, and it also uses NFC-A. And NFC as a part of RFID It's very specialized one of the most standardized, and so basically it gets standards for everything, and security, some kind of security. Not perfect, but acceptable. And one more, like a huge thing, is the SubGhz. So basically, it's in some cases when you have like some big space, you cannot control your device with infrared or NFC. You have to use something different, and that's where radio comes. And all those kind of devices that can control, for example, doors, like cars, we call it SubGhz. So, in big IT, what we have? So if we're talking about networks, so mostly we're talking about networks. We have Metasploit, we have Nexus, we have Nmap, Mascan, all kinds of like network scanners. Also, we have tools for decompiling software, analyzing it, and basically, you don't have. There are a lot of examples how to use those tools, but is it same in like pre-IoT things? It's actually not. And yeah, as I told, some areas were completely neglecting any attempts to be like to introduce security into them. For example, infrared, it's just not secure by design. Like no protocols available on the market contains any kind of security on the inside. No cryptography, just a plain static codes. As for RFID NFC, it's not a one protocol. It's a lot of them, a lot of transports, a lot of different layers, and some of them trying to be secure. For example, payment industry, PCI-DSS plus payment card industry, we're trying to make NFC secure by introducing standard called EMV, which use it for Apple Pay and Google Pay. And for like normal cards, it's also it's trying to be secure. It's not always, mostly because some implementation are kind of trying to cut corners and not implementing all features that are required by the standards. As for RFID NFC, there is probably one really good tool. It's called the Proxmark. So basically, it's a software-defined radio for low-frequency, high-frequency RFID. It's really good because when you have physical standards, you usually have to have like specialized hardware to receive and transmit signal. What Proxmark do, it just allows you to generate all kinds of signals in software. And it's kind of nice, but it's a little bit limited in terms of you have to have your computer with you, you have to have this device with you. It's actually quite small, but yet still requires a lot of things to bring with you. Then we have SubGhz. Also, it's not one standard, not one simple standard. And there are a lot of different vendors who uses different frequencies, different types of modulation, different security, some of them actually using encryption, some of them inventing encryption. Sometimes not very good one, but they try. Okay, and what can we do with it? Also, there are no standard tools. And the only thing that you can use is actually software-defined radio. And for SDR, we'll talk a little bit more about what is available on the market and what you can use to analyze what exactly in front of you and how we can like crack it. And one more system, last but not least, it's iButton. Basically, it's a one-wire-based protocol. Use it for different kinds of access systems. And the first implementations were trying kind of be secure. Totally failed, and we'll talk a little bit more about it later. Okay, let's start with infrared. So it's one of the oldest things, as old as infrared LED emitting diodes, something from 70s. And in 80s, we already were having standards. So you can imagine that it's a super old thing, super simple. And the first one was actually by Philips. It's RC5. Then Japanese manufacturers came in with their own standards. And NEC Sony, Samsung, and they all come and they invented their own standards. They also was very simple. The idea is just to use modulated medium, so infrared light, to transmit and receive signal, transmit on the one side, receive on the other side. And it's not going anywhere because it's super cheap. It's going to be used in some specific products. At least if we see TV, probably we can say that right now it's using infrared. So some TVs are trying to switch to another types of remotes, for example, Bluetooth or energy, but still there are a lot of devices with infrared. So it's not going to leave market any soon. So air conditioners, TV remotes, light control, toys, and what's most important that some manufacturers is actually trying to build like systems for different kind of businesses based on infrared, and it doesn't look good. For example, in the gas stations, at least in the United States, we have one example when a gas station like sign that says how much current the price for the gasoline. It's actually controlled by infrared. And it's not meant to be used that way, but okay. Yeah, so there are mostly, the hardware is super simple. It's just like a very simple transmitter with one LED, and then you have top that receives this light. And probably you have some kind of microcontroller that decodes the signal. There's no security in this protocol, and it's kind of broadcast, so treat it as a broadcast. So if someone is transmitting, then you can pick this signal from, say, like 30, 40 meters, and then reproduce it. So what kind of attacks we can do with it? So the simplest one, if you see like a TV or this kind of projector, you can brute force it with just a set of like off commands for different kind of protocols, and then it will just shut off. In some cases, it may be, in some cases, maybe it's not a big thing. Maybe it looks like not a big thing, but it will definitely affect business, especially if you're like marketing something, or maybe showing important information. Maybe you have like a queue system that like calls next customer, and then if someone will turn it off, it kind of sounds sad. Yeah, and in some cases, when, for example, someone will change settings for like air conditioning system or some other like important thing, it actually may like have a big impact, especially if the temperature is something like 30 and then someone is turning heat on. You can easily get someone died because of heat. So yeah, the conclusion will be, no, we will come to conclusion. So what can we use for analyzing the protocols? So one of the most popular one in do-it-yourself electronics is actually Arduino IRMP. But there are no like tools that's universal. Pretty much no one cares about infrared. And if you want to do something, you will have to do it by yourself. And we decided that we will put it into Flipper, and Flipper actually supports a lot of different infrared protocols and different instruments for analyzing raw signals. So how can we protect systems that use infrared? Don't use infrared. It's dead. It's dead. It wasn't meant to be used that way. And the peak for infrared was IRDA. So it's Infrared Data Association. And they did a lot of things. They were trying to make standard communication. They were trying to bring some kind of like the structure into this house. But it's dead. It's not here anymore. And sooner or later, infrared remotes will die. Okay, next topic is RFID. Like RFID is one of the oldest technologies, probably a little bit less older than SubGhz, but yet still. So when we will talk today about RFID, I mostly mean low frequency RFID. NFC is like a separate one, and UHF RFID tags is also out of scope for today. So the first idea about RFID was mentioned in 40s, and then the first devices which actually were starting to use RFID was in 70s, and it was electronic toll collection system. So it kind of useful thing, and from then people started to use it for access control systems, and it's not that common here in Japan, but like Europe and the United States still using at least Yamarin, HIT, and Indala. One of the most popular in the United States was Indala. So basically, it's a standard by Motorola. And there's one thing that makes them all common. It's the lack of security. So basically, those standards are just identifiers. Sometimes it's like 20 bits, 16 bits, like 100 bits. Yeah, and yet still, you can imagine that there are some kinds of attacks that just can brute force all those IDs and get access to some system. And also those systems use it for animal tagging. So one of the most popular one is FDX-A, and in some cases Yamarin, YM400, and tracking systems. So there are some specialized tags that allows you, for example, you are like sticking it on container with some goods, and then like system in the port automatically tracks where your container is. Quite nice things, and still, surprisingly, still here. So no one is changing them, no one is replacing them. Then ETC systems. So also one of the oldest, probably first one was in the United States, and then we have ETC systems here, but they're already using not low frequency but high frequency. And one of the most popular uses in nowadays is actually keyless entry into the car. So basically your remote is actually dual technology one. So one is SubGhz that allows you to open the door, and then when you entering into the car, you have a feed part, which actually can be scanned like some volume. And the second one is actually allowing you to start the engine. Yeah, so how it looks like? It looks like that. So we have control systems. We have a lot of different kinds of the tags. It can be a card, it can be like something nicer, it can be pretty much anything. And there are some special types of devices that actually allows you to copy one key to the blank. And yep, so what can we do with it? So the simplest thing is copying the card. And you don't need to like spend a lot of time or efforts to scan someone else's card. It's really simple. So, and basically there are some special types of antennas. Like they're a little bit big, but they can be hidden into some kind of case. And then you can scan cards with a distance like 5-10 meters. So those technologies not secure in terms of design, and they're very easy to copy and clone. Then you can easily intercept communication. So some tags trying to be smarter, but trying isn't enough. If it's not encrypted, then it can be intercepted, it can be recorded, and then in some systems it will allow you to gain access to the system. And what's most important, that since a lot of those technologies uses very limited space in terms of amount of combinations, like 16 bits isn't that much. You basically can brute force it. And in some cases, they use like default zeros or FFs, and you also can access it in like a couple of seconds. So what you can do, how you can analyze what exactly you have. So basically, Proxmark, same thing. Flipper can do a lot. And then we have some really nasty products from AliExpress. Basically, it's like a big antenna that you can sniff interaction and keys with from like a very long distance, something like 5 to 10 meters. And obviously, you can do it yourself, because the transmitter and the receiver is super simple. So what we're going to do with it? Don't use RFID for mission-critical systems. OK, next thing. This is the next generation of RFID. So NFC, it's basically the same thing, but a little bit higher frequency and better standards. And one of the best things about NFC is that people really tried to make it standard. And we have like ISA certification. We have ISA level. Then we have GSMA association is actually also trying to also tried and also did a lot of things to standardize working with NFC. NFC Forum, one of the biggest one, and more. And we have this. Yeah. So they were trying hard, but it's like, I want to make a new standard which will make all other standards obsolete, and then we have this one. So basically, we will talk about Japan a little bit. In Japan, it's kind of simple because you have only one company which was doing this. It's actually Sony, and we have Felica. As for other parts of the world, the most probably the biggest one is NXP, and they've been working on MIFARE for a long time, and they have like a big portfolio of MIFARE chips, starting from the simplest one, like NTAX and Ultralight, and ending with DSFire, which is actually quite advanced. And then we have like those who works with payments probably know about JavaCard. And then at some point, JavaCard became compatible with NFC, and then you have another type of transport to your JavaCard, and a whole new level of security if it's properly implemented. If not, then we have what we have. So, where it's used mostly most time. The most common use is actually access control systems. Even here we have NFC-F. It's Felica. It's Felica standard, and it looks like they don't use like a sector to store data. Instead, they just use unique ID of the card. I will explain why it's bad. It's bad. Yeah. Then we have some animal tags based on NTAG Ultralight, and we also have tracking systems for the containers, products. We have ETC systems based on NFC. And then we have keyless card access systems, also based on NFC. And online-offline payment system. That is actually the most important part. The most important and the most paid one. For online payment systems, it's Google Pay, Apple Pay, MasterCard, Visa also have like an NFC payment part. And it's called EMV. So they all tried to standardize it as one standard that's like the same for every payment processing company, and they call it EMV. And offline payment systems. And that's where things becomes complex. In general, we have the most like popular use cases for offline payment systems is actually subway and different kinds of transport. Mostly public one. And those systems is based on the idea that it's nearly impossible to process that amount of transactions. So we just will do it locally. So it's like the reader inside of your access system is just like asking card, OK, how much money you got? And card saying, OK, like 50. And reader saying, OK, subtract 15. And then it subtracts. And MIFARE Classic and Felica is actually implementing this exact thing. And if you're using Suica or any other local Japanese offline payment system, they do have Felica on the inside. And there are some problems with it. They're all based on the idea that your terminals is secure. So in case if someone somehow got this terminal and then extracts keys, then it can forge transactions. But sometimes you don't even have to get like a real terminal. Instead, you can sniff interaction with the card and then reconstruct key data and authenticate and change data by yourself. And that's what happens with MIFARE. So MIFARE Ultralight is like, they were trying, but not much, like a little bit. And at the end, basically you can copy this card. It doesn't like require any type of authentication. It doesn't have a session for encryption session for key exchange and data exchange. And at the end, we have card that actually can be easily copied and rewritten. And those companies like Subway Systems, they adapted to it. And they started to do reconciliations. So basically, like every 30 minutes, they do reconciliation of like how much money should be on that card. And if, for example, some transactions tells that at the point when they do reconciliation, amount of money on the card is somehow different, they will just block it. And it kind of works, but crunchy. And yeah, for MIFARE Classic next generation, for Felica new generation, and MIFARE DES, it's actually a little bit better. At least session is encrypted. So before you actually will do transaction with the card data, you will have to like generate session key and then all exchanges kind of secure. There's one problem. It's secure if your like random generator is good. If it's not good, then you have MIFARE Classic. Okay, and yeah, in some cases it's used for like authentication. There is an NFC U2IF standard which allows you to use it as a secure key, but it's kind of secure. It uses JavaCard on the inside, and plus minus good. Yeah, and JavaCard transport. So basically, you can implement any kind of JavaCard application that uses NFC, and as a transport, it will be good. Yeah, it looks like that. So mobile phones, Subway, payment terminals, Amoeba. Yeah, actually, Amoeba, it's ultralight, it's an NTAG. They also, Nintendo was trying to make it secure, a little bit. And basically, you can reconstruct passwords for changing data just by getting serial number of this card. And you can buy Amoeba cards, fake Amoeba cards that actually behaves exactly like real Amoeba cards. So what kind of attacks can we do? Yeah, in some cases, we can do card cloning. Like for ultralight, it's super simple. In some cases, we can sniff key data and reconstruct a session and get data and then emulate it. And what happens if we have it? It's such a broad thing. In the best case, you can get like access to some critical infrastructure. You can get some money from payment systems that you don't actually have. And yeah, it's a very important thing. And Rakuten also has a Rakuten payment system called AD, which is based on Felica and offline payment processing. So what do we have? Proxmark. Sadly, but like the most powerful tool for this kind of thing is actually Proxmark. Then we have most of the common attacks we have on Flipper. And in some cases, you will have to design do-it-yourself hardware, especially if we're talking about ultra-high frequency radio attacks. They're very specialized, and sometimes you can buy it, sometimes not. So how can we protect? So basically, everything for NFC is already in place. You just have to follow latest standards. Don't use legacy cards, legacy equipment that have issues with random generator. And yeah, when you're using cryptography, don't design it by yourself. Do audit from outside to ensure that your flow is correct one, and what you're doing is sane. We'll talk about sanity in next topic about SubGhz, because some vendors inventing really crazy things in a bad way. And they saying that it's cryptography, but it's not. Okay, one of the most important topics in offline payment processing is you should know that at some point someone will get access to your terminal and will extract key data. And at that point, you will have to invalidate all keys that you have. And like you're basically at this point, your card processing system will fall apart, mostly because you cannot trust anything, any event, any transaction from this point cannot be trusted. Yeah, and you have to do damage control in that case, and reconciliation in case if you always do reconciliation. And at some point, you will find that something went wrong, and your keys was exposed. Okay, SubGhz. Also one of the most popular thing, at least if you have car, you already have SubGhz transmitter and receiver. And it's actually SubGhz not one thing. It's so many different things that it's just unimaginable. So all types of modulation, all types of encoding, all types of protocols on top of it. And because of that, you are basically on your own with trying to figure out what it is, how to decode it. And what's most important that in many cases, those transceivers are designed on top of very cheap hardware. So basically this hardware doesn't have enough performance to do complex cryptography. It cannot do asymmetric cryptography. And at the end, you will find that it's not secure at all. So there are like 4 main bands which are marketed as amateur bands. So basically, you can use it for anything you want. And it's 350 megahertz, 433, 866, 68, and 950. In Japan, we have 315 and 915, but it's not limited only with those frequencies. So some frequencies are just allows, there are some exceptions. For example, if your transmitter like car fob transmits for a very short time, so duty cycle is less than 1%, and at the same time it doesn't emit like more than 0.1 watt, you kind of can use any frequency. And it's becoming very difficult to find what exactly you have in your hand. What is helping is that every device that is certified actually have like FCC ID on the back. And by having FCC ID, you can find the documents which describes exact frequencies which it uses for transmission. So, there are some really simple things like 15 bits protocols that allows you to open something, and very complex one like, for example, LoRa. So LoRa is just mind-blowing thing. It uses chip modulation, which itself kind of magic, and then it uses like a special algorithm to extract data from it, from this chip modulation. And you can build huge mesh networks based on LoRa, and I know that some like systems for monitoring like power consumption actually using it. So it's used for car access, probably the most popular case. So if you have remote, it's 100%, 433 or something like that megahertz, sub-gigahertz remote. Then alarm systems, and that is actually becoming a little bit scary. So for example, in some buildings, you have all those detectors, which uses 433 megahertz for transmitting information about its state. And what we found is that in many cases, like receivers for this data is actually ignoring when device is not like sending data often. So for example, it's just like battery died, and this device is just not reporting that something died on the other side. And you can find that it's very easy to jam it. And for example, you can start fire and then use jammer, and then like fire system just will be silent. And that is scary. Then Internet of Things and wide area networks based on LoRa. It's also a huge thing, and because it's all about embed, it doesn't have all those tools to test what exactly it is, and it doesn't have same kind of security that we have in like a big IT. Then we have a lot of toys, home appliances, in some cases medical appliances like pacemakers. They also use sub-gigahertz. And it's just impossible to cover all kind of things that can be done with sub-gigahertz. So one of the most popular one, like car alarms, doorbells, power plugs. And you know what is funny? That some car alarms like this one, it's made by Chinese guys, uses Princeton. It's a very simple protocol that's super popular. Like all other appliances that doesn't require security usually uses Princeton. And so basically it allows you to use a doorbell button to open your car. Not very secure. Yeah, and what kind of attacks we can do? Like the most simple one is actually record replay. So if you're like staying in 100 meters from the person, you actually can pick the signal. And then when this person will go away, you can retransmit the signal and open the system. Like open, for example, door to the house or something like that. You can open cars, and probably you heard that lately Honda, the cars from 2019, 2020, they found the vulnerability in the protocol. Protocol itself was designed to be rolling code. Rolling code is kind of secure, but the way they implemented it, it allows like replay attack to resynchronize and open the car, which makes it super insecure. Same level of security as Princeton. So, and then in some cases, if we have rolling code protocols, for example, Keylog, it's one of the oldest by Microchip. And it was born from the idea, okay, if we cannot run IIS or elliptic curve cryptography on our MCUs, why not run something that kind of looks like? And then designed Keylog. The only one thing that they failed to understand is it's impossible to store. It's a symmetric cryptography, and it's impossible to keep this key secret. And basically, all the hackers do only one thing. They get the remote, and then they like extract firmware from this MCU, and then they get the key. And that's it. So basically, from this point, you can decrypt the payload, then reconstruct sequence, reconstruct serial number, and create the new payload that will open the door. And that's what we see in many cases for some other vendors, not Honda. And it's available on the market. There are a lot of black market. And it's kind of sad to see that last 20 years is actually not teaching us anything. So those remote systems are still on the market, and still in the new cars, and even 2022 cars, some of them, is still vulnerable to that kind of attacks. So in case of success, we will get access to this infrastructure, maybe car, maybe something else. And in worst case, we can do denial of service. And in some cases, denial of service is actually quite bad. So what tools we have? So mostly we will talk about software-defined radio, because it really allows you to deeply analyze what exactly the signal is, what kind of modulation it got, and what kind of receiver you have to create or maybe reconstruct it in GNU Radio. So one of the most cheapest and popular tool is HackerF. The results are RTL 433, but RTL 433 allows you only to receive signal. And HackerF allows you to receive and transmit signal. And there are more expensive tools like USRP, Lime, Pluto, that allows you to create your own base stations, which is also quite scary. And there are some software packages like GNU Radio, one of the most popular, and Universal Radio Hacker. And Flipper can do some. We support some specific set of modulation like on-off gain, frequency shift gain, 2FSK, MSK. But you still have to reconstruct configuration for receiving. Then we have Yardstick on the market, and a lot of different tools available on AliExpress, or you can just assemble it by yourself. There's no rocket science. So how can we protect from this thing? So don't use legacy cryptography. Use modern cryptography use elliptic curve cryptography with asymmetric keys. Do audit what you did. Don't trust like your platform. Don't expect that your key will be safe if the vendors told you that it's safe. For example, for STM, I can say that like the whole series from L0 to L4, from F0 to F4 is vulnerable to side channel power attack. So basically, when it's starting, you can glitch the power to some level, and it will allow you to read out data, which kind of protected. So basically, it means that you can extract data from MCU that tells you that it's locked, only because of this simple glitch attack. And you don't have to, it's very simple attack that can be reconstructed at home. You don't have to have special equipment for it. So, and the last topic for today is iButton. So iButton is the product by Maxim. And in 2000, it was huge success and very popular one. So basically, the idea was is like you have the key, and we have something like key that you can also use for accessing the door in your apartment. And it's based on one-wire protocol. It also uses, it can be a lot of different things inside of the same package. So basically, it looks like a button. But inside of this button, you can have all kinds of things. For example, you can have just a unique identifier. You can have a little bit of memory. And what's most important, you can have actually JavaCard inside. And with this JavaCard, you can already do something more complex, including proper payment processing. And where it's used mostly for access control systems. I never saw it in Japan, but it was very popular in Russia and Europe. And it's still used in some places in the United States. And also, it's used at factories. So some equipment uses iButton for like licensing systems. So you can like unlock license with iButton. So very simple thing. It's just looks like iButton. Looks like button and a key. Yeah, we do support iButton. And what kind of attack can we do with it? So the simplest thing what you can do with iButton is just to copy it. And because it's so the first iButtons which was on the market, they never meant to be secure. They was just like, okay, we just data storage. And that's what makes them very easily copyable. Then in some cases, there were some protocols which looks like iButton and also use the same form factor. And if iButton uses quite decent like key size, something like 132 bits, at least 32 bits, then some other protocols just uses 16 bits. And you can brute force it. And you can get access to the system by just brute forcing it. So brute force protection is also not a thing in most of those systems. They design it in a very strange way. So there are no like standard tools for analyzing what exactly you have. You will have to make it by yourself. In most cases, it's like a very simple circuits that can be connected to Arduino. And yeah, flippers also can do that. So how can we protect it? Yeah, from all iButton series, there is like only one thing that is really secure. It's a JavaCard. And if you want to implement your system in a secure way, use JavaCard, use modern cryptography, and do audit. So how are we going to live with it? That's a very difficult question because all those systems was like they design it one time, they go to production, and then they don't have like software update because software update is just impossible in many cases. And like all those fobs to control your car alarm and open your car is actually going to be that way till the new model will come, till you will sell your car and replace it with a new one. And that is kind of thing that we'll have to accept because it was designed in that way. And even modern cars, for example, Tesla, have one specific thing. For example, they do have like kind of proper access control system for opening the door and starting engine. But for some reason, they decided that opening like the charging port isn't very important thing, and they can just use static code to open it. And that's where we have like a lot of people just, so that is kind of sad thing to see about Flipper, but a lot of people just walking the streets and then opening this port for every Tesla that they see. Yeah, so most likely your car, if you have one, have some kind of security vulnerability in that part of the system. It's not like it's going to be fixed, just accept it. Yeah, and your house, so alarm systems in your house, if they're using SubGhz, you have, I mean, you already probably know that you have to like change batteries once in a while, but you also need to know that if someone will want to start fire and then like disable your system, it will be very simple task. Then, workplace. So also in some places you can find like different controls, like opening shutters, closing shutters, opening like doors, and in most cases they are also not secure. It only depends on how insecure they are. In some cases you can just brute force it without like copying that. In some cases you will have to take like to receive couple payloads from another remote to open it. So, and if you're designing such systems, please make it updatable. At least a little bit. And use modern cryptography, use asymmetric keys, use certificate authorities and the root of trust, which have root outside of your device itself. Because if like you are storing keys on your device, it's just a matter of time when those keys will be extracted. And Sony knows it, even with proper hardware and like designing PlayStation, there was still a way to extract key data from the storage that they have. And then sign like your images with this data and use it to start PlayStation. Question and answers.
Okay, any questions?
Can you switch on this?
How can I do that?
By flippers.
Yeah? So basically, what Flipper is doing, we have universal remote. What is universal remote? It's actually not one remote. It's a set of signals. It's like we scanned like hundreds, thousands of different remotes, and then we chose. It's actually powered on. You can check.
Yeah,
It.
green one.
And so the basic idea is we just transmitting the signal one by one. So and it takes the maximum time that we need to like turn on or turn off thing. It's something like 1 minute. And that's it. So those systems never meant to be secure. OK?
What is the story with Bluetooth? Why it's not in the scope of your interests?
It depends on what kind of Bluetooth we're talking. Because Bluetooth is not a one standard. It's a huge thing. And what's most important that it's a standard, but not standard. It's a standard in terms of there are some papers, but implementation depends on the vendor who actually produces like the chip itself. And in many cases, those implementations like bad. They're insecure, they're vulnerable. And in case, if, for example, your implementation running inside of the kernel, it makes the whole thing disastrous. And in most cases,
Everything you told us about, like
yeah.
so will you add the Bluetooth in somewhere future?
We do have Bluetooth Low Energy.
Oh, okay.
Yeah, and basically we can do some kind of attack. But for us, Bluetooth Low Energy is just a transport for mobile application. So the most important part for us is mobile application that can control Flipper. And for Bluetooth Low Energy, there was another issue with Tesla. That actually they were having like incorrectly implemented checks, and you were able to open any car with Bluetooth Low Energy. If it's enabled, then you can just open it.
Yeah, because I was asking because I heard that Bluetooth kind of getting a thing nowadays. So even in some sport equipments, they try to use Bluetooth transmitter to replace some mechanical parts like gears or breaks. So it's also be a concern, I would say. Basically,
So I would say that like the modern TVs from Samsung
yeah.
and Sony is actually not using infrared anymore.
Uh-huh.
They use infrared only for initial, like they're sending ID to pair devices, and that's it. And then they use it Bluetooth Low Energy, and it's so like one of the biggest thing in embed is that you always have constraints on resources. Less memory, less flash to keep your firmware. And what's most important, in many cases, you don't have standard framework. You don't have standard like Bluetooth stack, and you're inventing it from scratch. And what we see is that there are a lot of vendors who are inventing their own things, and at the end, they end up doing the same mistakes again, 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 and again. And in many cases, like embedded developers, when they implementing something, they often forget something important. And those things become insecure, like Tesla.
Is it so? Is there a way to make it some kind of like make a change on a systematical level? So before your presentation, I was thinking that the problem is there is no proper standardization. But during your presentation, I heard that no, there actually was some efforts to make. But the situation didn't change in the end.
It's a very human thing in terms of when you have a lot of papers to implement. It's just human brain get limited capacity, and the more you need to implement, the less chances that you will implement it correctly. And another side of this thing is embed development. It never was simple. It always was a fight for like a memory resources, making it like stable, and at some point, like many teams just lose it. They were trying, but they lost. And another thing that I think is somewhere there is like there are standards, but there is no understanding of what the standard is fixing, and there is no understanding of how to implement it correctly. It's like recently we had a conversation about certificate authorities, and if certificate authority doesn't have trusted root, and this root is not trusted in all those systems that working with certificates, the whole thing doesn't make sense. But it was standard, and people read standard and then implement it, but it doesn't work that way. You have to understand what exactly you're doing. And in many cases, when like someone is coming and telling you, okay, you have to implement sub-gigahertz radio secure and make it like work with my car. It just not always works like that. And without external control, without standards, without audit, and without understanding, that's where we're ending up.
So basically, what? So from previous presentation, when Chris showed us how the PCI organization works. So when different vendors came into the one authority or one initiative, so can this, I don't know, kind of like design could be implemented in the...
Yeah, we're doing it. At least in some areas. For sub-gigahertz, it's LoRa. So LoRa is quite advanced stack that's designed it to be kind of secure, and a lot of people actually implementing it. Then we have, for Bluetooth, we do have certification authority. We do have Bluetooth Forum, who is actually like doing the standards. But it just not always that those standards implemented right. For NFC, we have like ISA on the one side, and we have NFC Forum on the other side. And they're also doing quite well in terms of the standards that they publish. They're actually secure. The problem is that a lot of systems have a legacy with them. So, for example, this system started like 20, 30 years ago. And it's simply impossible to replace all those readers, all those cards. It will be so expensive that it's easier just to close and make the system from scratch. And in many cases, we see that greed and not wanting to update system is actually bringing a lot of pain later.
Last question, why some of the dolphins in your presentation was pixelated and some not?
Yeah, so basically we have a whole idea about like Flipper project is pixelated because we do like pixel screens. And the thing is, also the previous time when I was doing presentation, I've asked it to draw a little bit of them. So some dolphins with a high resolution. And when today I was trying to find like all dolphins in the same like drawing style, I just was unable to find it. So I used all of them because I like all of them.
Okay, I see. Thank you.